the Transportation for Better Life, Future Potential of Transportation and Urban Model Post-COVID Era. So in this second session, we have three excellent speakers, and they'll be moderated by the chair. This session is Associate Professor Dr. Sarawit Narupati from Chulalongkorn University, and the session to be focusing on digitization in transportation and logistics. So please, Jan Sarawit.
Hello, good afternoon, everyone. I hope you hear me well here and online. Okay, this session is about digitalization of transportation and logistics, and we have three speakers today. The first speaker is Professor KAMIJO from University of Tokyo. The second speaker is Dr. Passakon Prathombutr from DEPA, and the third speaker is Professor Dr. Agachai Sumalee from Chulalongkorn University. Okay, I think everyone agrees that digital technologies play a very important role in our daily lives, and I think we have common words for everyone like AI, smartphone, platform, and social media. We like to learn how we use it in transportation. And also we have some new technologies like autonomous vehicles, drone, artificial intelligence, and all others. So we like to learn this technology, how we use technology, how we embrace all this technology to mobility. And if we do so, what would be our challenges? So I think today we will have a great opportunities to learn from these renowned speakers, and they are quite experienced in the field of digital transformation, digital technologies, and I think I list some key messages that we can learn from them. First, what are the challenges when we apply these new technologies in practice? In case of digital maps, we call HD maps, and for autonomous driving. And how we use digital transformation in smart mobility. And we have some challenges in even the practical issues in terms of the possible solutions that we can gain once we use this kind of digital transformation. So let me first introduce Dr. Passakon Prathombutr, the Vice President of DEPA, and he takes care of smart city in Thailand and international smart city network. He is also frontier in the field of intelligent transportation systems. He is editor-in-chief of ITS journal, and he will show us the concept of digital transformation in transportation field. And we hope that we learn how we build digital transformation in mobility and also for the smart city, please.
Thank you, Dr. Sarawit. Okay, please allow me to walk around here so I can see the slide. It's okay? You can see on me on the stage. It's fine? Okay. So from my background, I'm from the DEPA, so I'm in charge of the Smart City project in Thailand. So my talk is about the smart mobility. It's under smart cities. There are many sectors in the smart city area, like a smart environment, smart energy, smart people, smart living, and smart mobility is one of them. There are totally 7 smartness in the area of smart cities. So I will show you one of the 7, which is smart mobilities. So, okay. I'm not sure is this working, this one. Okay. So this is my topics that I want to show you, the smart city and the smart mobility concept. The showcase from Chulalongkorn because 2 of the speakers from Chulalongkorn. So I show the showcase from Chulalongkorn. And digital transformation, and finally the technologies that coming in the future. Okay. Why we do need the city transformations? So every sector, not only the cities, the media sectors, even today we still need the Zoom is an online presentation. So it's disrupted by the technologies. The transportations also be disrupted. Even the cities, we need some kind of change. We have to change it very fast to adapt ourselves. COVID is coming. COVID is kind of the energize to make it change faster. It's a catalyst for the transformations. Everything in the world could become, we could get the data. Even the lighting here, we can get the data. The energy is consumed from the lightings, how many people walking nearby in this room. So we can digitize everything to become the data. And we use this data to transform whatever. For data from the cities, we use the data to transform the cities. This is the why, how can we get the data? Today, it's many gadgets, many sensors. It's cheaper and cheaper, and we get more and more data, and that it become big data. So we can utilize the data to become the forecastings, anomaly detections, or we can do the plannings using this kind of data. So it's the new paradigms of the solutions. And like I said, in Thailand, we have the concept of smart city, as shown here, but keep in mind that the technology is just the tools. So we don't force the mayor or the city to utilize or to use the technologies. It has to be by design, depend on the requirement or the pain points of the cities. Not because we have the technology that we make them to use, but we have to start from the pain point, the requirement first, not from the technology first. So it's not the technology oriented. And we have 7 smart for Thailand, but anywhere in the world they have different term, different concept. But in Thailand, we use the 7th area. And okay, let's focus only for the smart mobilities, one of the 7 smart area. So you see on the top that we have a lot of problems, the requirements. So it depends. Some cities may have some different requirement. And in some rural areas, so maybe some different requirements. But these are some common the requirement that maybe we have some common solution also. Okay, once we define the smart cities into 7 areas, so what is the objective or the target? So this is the ultimate goals for each smart that we have agreed on the level of the government, the top priorities. So in the area of mobilities, we need to reduce the number of accidents. Must be less than 12 people casualties from the 100,000 population. And the percentage of the commute satisfactory, it should be greater than 60%. But this is the ultimate goal. But we have the sub goals under this ultimate goal. Here, let's see that in Thailand, any city in the level of maybe the municipalities, they can submit the proposals to the government. My office, DEPA, we are the secretariat of these government committees. So any city, if you are ready, you can submit the proposal to DEPA. And then if you pass the criteria, you get the Smart City Thailand logos. It comes with the incentive from the government. For example, the tax exemption from the BOI or the budget from the government. So these are incentives. But you have to submit the proposal and pass our criteria. So this is one of the cities. Today we have 15 cities. 15 cities have already passed the criteria. It's not the whole Bangkok. For this example, Samyan Smart City is just the one zone. But they have their unique proposal they have already submitted and already received our trophy, our Smart City Thailand logos. So I will show you what happened in Samyan. You see that this is sorry, it's in Thai, but this is overall the proposal that have already submitted. They have to submit what is the visions, what is the business models for the investment in the seventh area. If you want to submit all the seventh area, what kind of the proposal of the project? So we do have the proposal of the project that there is a plan for at least 2 years. So I will not go into the details, but in the area of the mobility, so you can see that they have a lot of activity that I got to show you. Here is the objective to make it more accessible for the convenience, efficiency, safety, green, and innovation. Let's take a look. This is one of the Chulalongkorn that in Samyan City, Samyan Smart City area. They have the green and sharing facility for the commuters within the Chulalongkorn or Samyan area. It's not only the Chulalongkorn. It should be cover the area surrounded and nearby. And here for the Hamo is another the car sharing. So you can see this is the kind of the transformations. It's not in our past that we use only the public transport. So it is car sharing that means the commuter can drive by themselves, or hop cars is one of the founders here. This is a car ride sharing, and this is the pop bus Chulalongkorn. I go very fast here. So this one is the Move Me is a EV tuk-tuk sharings with the application that you can share. And I think it's very, not only Chulalongkorn today, but they have many areas in the surrounding Bangkok. So Chulalongkorn is like a pilot for the startup. So Move Me is one of the startup company that they can try out in the Chulalongkorn area. This is another trials from our startup in Chulalongkorn. It's called Leaf. It's an EV scooter. So you see that a lot of technologies, a lot of the data is happening and coming, and they can take the benefit of the data. So they know the commuters from point A to point B, how to arrange the scooters to make its balance for the user. It's another one is a co-bike. And Luna is a van sharing. Smart parkings. So let's go back to the concept. So you see that in 19,000s, in New York, Fifth Avenue, can you spot the automobile? So you can see from the circles here, just only once automobiles that use a gasoline. But after that, 13 years later, you see, can you spot the horse? Just maybe around here, just one of them. So my question is, what is next? If you go down, can you spot the autonomous vehicles on the street? So the same questions. But it takes, you see, today is 2021. It takes 100 years almost to make the change. This is the future. So what is coming? You see that it's not only the EV, but the connected, automated sharings. This is the future, but you have to spot this one down there on the street. But it's yet to come. But I bet that it will come very fast, and the circles of change will be short. So my idea is to transform the mobilities. This is the keywords. The first is digitizations. The digitizations mean to make the digital data, how to convert from the paper-based to the computer-based. that you convert it to become the computerized data. Once it's become the data, like the number of people in this room, you can convert into the data. And then once it becomes the data on the computers, you can transfer it, you can combine, you can curate it, you can send, you can submit, you can share. So that's why we need to convert into the digital data, right? That's why we need the first step, we need to digitize it from the manual, from the paper-based to the digital base. And then we call this digitalization. This is not just to convert the data, it is convert the process, the whole process. To make the e-payments, to make the e-commerce, is the process, the whole process. It's not the data. And finally, the whole ecosystem, we call this digital transformations. Let's see the example here. Digital data, the number of vehicles passing the toll booth, but if we can detect it, we can read it using the CCTV, that means we can digitize, we get the data, number of vehicles, the license plate, what kind of the license plate, who is driving that data, or from the RFID, we can detect it, we get the data, and then we process it. We can, check how many balance on that account that passing the toll booth, and then we can, the ecosystem to make the whole payment connect to the banking system. So this is why we have start from digitization and digital transformation. This is the way that we do the transformation. And this is for example. And then we get the new paradigms of the solution, unlike the manual way. So because we have the process of digitalization, digitize. And it happens today because of these technologies. It's existing today. You see that, I take this photo 3 years ago in Bangkapi Junction. And you see that a lot of gadgets, a lot of sensors have already installed on the roadway. So even in the taxi, they have their own GPS or the front camera. So everything here could become the data. And if we got the data on the cloud, we can do some processing. We can use the AI to make it automations. So you see that there are a lot of opportunities because of the first step is that how to gathering the data. It could be from the mobile phone or from social media that input by the human beings. Yeah, like they report to the radio station that there is a traffic jam on this street. So that is from the human being. It's okay because the human is another input process for the digital data. And today, so we are about this time, we are going forward to another step of the what we call the virtual world. In this step, 2025, you see that we have a cloud computing, but it's not only one cloud. The cloud is in your pocket. The cloud is on the edge. It can connect to each other, like a blockchain that is coming. You are become the bankers. You don't need the centralized bank. It's a decentralized. You have to make your own contracts, smart contracts. Because of the technologies is available. Many opportunities for the new paradigm, even the transportations. But today, the financial technologies is coming. So you can see at the, we call it the cryptographies, a lot of the farmings for the person that try to make the money from the blockchain. Because even the NFT, non-fungible tokens, you can sell your digital art. So this is a lot of opportunity for the new technologies. So I just wonder what is happening on virtual worlds. Maybe today we don't have to meet in person. We can meet on the virtual world. thank you for the ATRANS that have already started the metaverse trial. So you can try out. That message come very early than I expect. So I just excited. I want to try the ATRANS metaverse. And I call it another word is digital twin. The digital twin is different from the metaverse because it linked to the physical world. Let me show you this picture. I take this picture from the World Expo in Dubai. I talked to the Siemens that they are the company that manage everything in Dubai's World Expo with the area of 4,000 square kilometers. So you can see that they have the physicals and the digitals that is twins, they align together. So they can control the energy, the pollution, everything that from the sensor. And they can do the anomaly detections, anything that happens. They can do the forecast for the power consumption. They can do the plannings. So a lot of things it form the digital twins. Or they can do the simulation to say if there any some accident here, how can we move the traffic, reroute the traffic. So they can do the simulation before they apply to the real world. So this is the benefit of the digital twin. Physical and digital together, we call it digital twin. Let me go back to this slide. So many technologies above here, AI, big data, edge computing, cloud computing, IoT. So this is the technologies. But this is the process, the benefit. Because of that technology above, so we can do monitoring, forecasting, anomaly detection, planning, control and command, decision support system. So many things based on the technology upstairs. Okay, and this one is the example from Yala. Yala, this is a southern city in Thailand. So in Yala, we use a mobile phone to detect the movements of the people. This is to control the COVID pandemics. So this is the real case. When people have the mobile phone, we can track that. So this is why we get and take the benefits of the digital data. Let me skip. So it's very quick. This one is the autonomous truck in the seaport, the deep seaport. So I take this from the DP World in Dubai World Expo. They have the exhibition to show that we don't need the driver for the vehicles. You can see that it's the driverless vehicle, but it's in the closed system. So this is another key that how can we, introduce the technologies. So if we can do the closed system, all right, the pilot area, we can trace tie on that. But this is I think it exists in Thailand. We also have this kind of technology using 5G in Slan Chabang. This is another one that you can see that they have the box bay. The box bay is the condominiums of the containers. So they can take off the container, downstairs. They don't have to put it in the stack. This is the way they design. And the robot can manage the containers. And finally, this is the Hyperloop. But it's a Hyperloop for the containers, not the Hyperloop for the passengers. So this is the future that they're going to transform the deep sea port. This is from the World Expo. Okay, I think it is time.
Thank you very much, Dr. Passakon. Let me save the question for the Q&A sessions. And now let me introduce Professor KAMIJO from University of Tokyo. I hope he is online now. And
yes.
Okay.
Hello.
Hello.
Hello, Soroid Sensei.
Hello. Yeah, I already introduced you to here the on-site participants. So your topic today, you will focus on the new technologies that we're going to use, especially autonomous driving. And you will introduce many interesting like eyes or LiDAR and brain processing and the problems that we have for the high density maps and how we run this kind of autonomous driving in the city. Okay, floor is yours, Professor KAMIJO.
Okay, thank you. Thank you very much for your introduction. So, and thank you. It is my very honor to be here, invited for the ATRANS meeting this year. And today, as in the introduction, I want to talk about benefits and some problems to be solved for the future in the digital map for autonomous driving application. And my talk is based on our research experience today. And as everybody knows, LiDAR and computer vision is used for the autonomous vehicle applications. And for example, SLAM is a simultaneous localization and mapping. It is a basic technology and many researchers doing for the localization. And also, this is the case of without map. But once the digital map is provided from the map company, everybody uses this map for the localization, doing a matching of the digital map between the real sensing data from LiDAR and computer vision. And many of the digital map for the demonstration of the vehicle application is made of point cloud, which is taken by the LiDAR. So today's discussion, I would like to introduce about some discussion about how the digital map could be, and also what is the problem. So at first, this is a benefit of the digital map for the vehicle applications. So for example, so as I introduced in the previous slide, the point cloud is used for the self-localization in the autonomous driving. And also today, we call the high definition map, HD map, is getting a popular concept among the autonomous vehicle researchers and the OEMs. So it contains more rich information as buildings or roadside facility like traffic signal, and also the physical lane configuration, and also the road markings. And it not only the physical data, but also it includes semantic information like lane semantics of the right turn lane or left turn lane, or speed limitation, and the traffic sign, and speed for the to the traffic rule, and also stop line and the pedestrian crossing, and the direction guidance. And also those information can be used for the motion planning. In addition to that static information, so dynamic information is considered to be attached on the digital map and delivered to the drivers through the digital network for the autonomous driving. Like a connected vehicle, right? And for example, macroscopic events as a road construction or traffic regulation or damaged road, if those kind of information can be attached on dynamically on the HD map, and also the mesoscopic events like a congestion, accidents, those kind of information can be also attached on the HD map. So at the beginning of the discussion of the early stage of the dynamic map, more microscopic events as a positioning of the each pedestrian or each vehicle can be attached on the HD map to make the motion map, motion planning or collision avoidance. But that kind of microscopic discussion has disappeared because everybody recognized that for the collision avoidance, the time requirement could be the less than 1 minute, 1 second, like 100 millisecond. It is not feasible to use public communication network to put those microscopic information onto the HD map. There is no time for the collision avoidance. So everybody is thinking about macroscopic and mesoscopic information on the HD map, not the microscopic information on the digital HD map. And the new topic of the digital map is the object detection aided by the HD map. As you know, so for example, level 5, so complete HD map has a complete information about the traffic sign or traffic signals or traffic, those kind of information. And through the connected vehicle, so the driver's vehicle can know that information. But before the level 5, we have the transient time for the, I don't know, but I guess another 20 or 30 years, we cannot shift to the level 5, and we experience a transient time, mixed traffic with autonomous driving and humans drivers. So in that case, sensor can be used for the detecting the traffic signals or traffic signs and also variable message signs and so on. But sensors has an error. So in order to improve those errors, HD map can be used for the object detection. Later in this presentation, I want to introduce this case from our research. And the problems to be solved to make use of the digital map for the autonomous vehicle application is like this. For example, how the digital map can be updated. Some OEM and the map company considers about the cloud sourcing. Yeah, it's collecting the sensing data from the vehicle and fix the digital map. And or someone is thinking about a tailor-made update for the sensing. So there is a very interesting example from the Google Map in Japan. What happened Google Map in Japan is several years ago, Google decided, as everyone knows, so Google Map in Japan is provided, the data is provided by the Zenrin company in Japan. Zenrin is a famous map company in Japan, you know. But several years ago, Google decided not to use the Zenrin map anymore, and they will do the updating using cloud sourcing, but never successful, and going back to the Zenrin data. That's a very interesting phenomena we experience in the digital map already. And the second point is how the digital map should be standardized among countries or map providers, map companies, and OEMs. So for the standardization, we need to consider about what is a format available and suitable for the digital map. In other words, is the point cloud feasible for this kind of standardization? This is another thinking, because point cloud is used for the demonstration for the many universities and the OEM companies. But many of the digital map is a current digital map for the car navigation system or other of usage is comprised of the vector data and the polygon data. And also even the HD map for autonomous driving considers the vector map as a physical data for the lane information or building and so on. So what should we do? And how the quality of the digital map should be defined and evaluated and secured, and also by whom? By whom? So how secure or how certified this digital map has a good quality for the localization error? And who qualify this? The final point is everybody believe LiDAR is the best sensor for the localization and very, very accurate. But even the LiDAR has some problems. So in adverse weather condition like a heavy rain or fog, LiDAR doesn't work even for the localization in that case. And also, if the weather is good, no fog, very fine, occlusion effect occurs. It means the beams of the LiDAR could be interrupted by the surrounding tall vehicles like a truck and buses. So in that case, we need to consider more about the passive sensor fusion, mitigates the occlusion effects or adverse weather condition affection in the conjunction with the digital map information. So let me go through. I have another 5 minutes or 7 minutes. So I would like to introduce to answer the question I talked in the previous 2 slides. I will give you the example from our research. This is an example of the make use of the HD map information in order to improve the sensing by the computer vision or LiDAR in the adverse condition like a night time or rainy situation. So HD map has information of the position, 3D XYZ position of the traffic signals or traffic signs, and combining that information to the image and put into the deep neural network. This network detects traffic signals and traffic signs very clearly and accurately compared to without HD map support. So this is the result of the deep neural network. We use the RetinaNet for the deep neural network and combined with the HD map information as a region proposal. For example, nighttime image, the detection is drastically improved using only the computer vision, like this. And this is a benefit of using HD map, of the state-of-the-art discussion about using HD map for the sensing. And next, I want to introduce some researches to clarify the problems to be solved for the futures. So as I mentioned about vector format, so many of the digital map is configured with vector format already. And we had an experiment, research to how to combine those vector map with point cloud data into as a HD map. So we call it the vector NDT model. NDT is a normal distribution transform. NDT was used for the localization using point cloud map without vector data at first. And we improved this NDT model into the vector map. This digital map format has a vector map, vector data combined with the normal distribution information around the vector map. The normal distribution is calculated from the point cloud itself. It means a kind of a summary of abstraction of the point cloud onto the vector format. And this can help the combined digital point cloud data into the conventional vector map format data. So matching between the two different type of map. And we performed the experiment using this format in the Shinjuku, and confirms that we have this format has a same quality for the positioning, localization of the vehicle, just almost the same as using a point cloud data. And a very, very less amount of data, consume the less amount of data and the processing time of the CPU. And another problem is how to evaluate the quality of the digital map. This is another research from us, and defining how the digital map has ability for the positioning. Because, for example, very extreme example, there is a one pole and no building other than one pole. So in that case, we can identify the distance to the pole, but 360 degree, we cannot identify the 360 degree. So this makes error for the positioning. So inspired from those kind of many discussion or some parallel wall, we just identify the lateral position, but we cannot identify the longitudinal position. So we make those kind of many discussions, and we identify the parameters to evaluate how the digital map has an ability for the self-localization accuracy. And we again performed the experiment in Shinjuku area for the, and this is an experiment of to evaluate the ability. So blue line is a real error, and these three lines are our calculation of the possible error. And this is a very good example, and our estimation is quite similar to the real error. So we can evaluate how the digital map has a performance for the localization. And this is another experiment of the occlusion effect by the tall vehicle like a bus. So this is our ego vehicle, and this is a bus surrounding the ego vehicle. And this is an occlusion effect by the bus. So we performed the experiment in Shinjuku, and this is a result. If this is the range of the occlusion ratio. If the occlusion ratio becomes more than 60% or 70%, convergence of the calculation of the localization drastically decrease less than 50% like this. And even the converged case, error becomes larger compared to the non-occlusion cases. This is a non-occlusion cases. This is a non-occlusion cases. And this is a occlusion case. And this is a occlusion case. So, and to solve this problem, we developed a dedicated GPS technology, which is very accurate even under the urban canyon situation. They're supported by the 3D digital map to estimate the reflection from the 3D digital map to correct the length, the pseudo range from the GPS satellite. So combining with the this technology with okay, I will. Okay, can you hear me? Okay, so I will finish in 5 minutes. So this is an example of our experiment using the GNSS on the IMU, inertial motion unit, to identify the without LiDAR, only using a passive sensor with a GPS, IMU, and also the computer vision to be more accurate lane identification. It was the accuracy of the positioning was less than 1 meter finally, and it is enough to identify the lane without LiDAR. And the final scenario is under the bridge case. I know that exact in the Thailand, Bangkok has a many bridge on the road. In that case, even the GPS doesn't work for the positioning. So, and also this very similar view repeat under the bridge. It is very difficult to identify the positioning even with the LiDAR because in that same view. So we did the experiment, the only looking on the road marking, and combining with the IMU data, how the positioning can be performed under those kind of a blind situation. So as a conclusion, and in my talk, benefits and the problems of the digital map for the autonomous application were discussed in my presentation. And we should recognize some problems to be solved remains for the digital map standardization and the real use for the autonomous driving. Thank you very much.
Thank you, Professor KAMIJO. He explained a lot in detail on the technologies that he's going to use. You can see behind the scene, we still have something to go. Let me make it correctly. HD is high definition mapped along with like LiDAR and other GNSS technologies. Okay, let us move on to the third speaker for today, Professor Agachai, and he will come and talk about practical digital transformation, especially the cases in Thailand, please.
Hi, good afternoon, everyone. So very nice to be here again and always enjoy giving a talk here at ATRANS. So I'm coming from the two perspectives today because actually we heard a lot already about technology advancement and how digital transformation can be made in our life. What I'm trying to explain today is that how it's actually applied to the current situation in Thailand in particular. Okay, the attempt that we apply some of this technology to transform some of our service and operation. And secondly, I will make my personal observation as I've been involved in a lot of these cases that I will present today. I will give you a very sort of humble and very straightforward my evaluation on what's going on and what could be done to make it better. So I think just to recap what we know, transportation is good and is bad at the same time. So in the past, I think more than 2-3 decades, we try to solve this problem to improve our impact on the society. But still, we cannot solve all these problems at all, actually. But recently, we have this new technology that, we heard from the first speaker already, that a lot of new technology on the IoT, the AI, the communication network that allow us to be more responsive to the way that we provide a service to the society and how we can optimize the service to reduce the impact at the same time. And this is the, promised land that now everything can be managed, like why the very efficient operation of the vehicle themselves, communication with the system, with the traffic signal, and a lot of things still need to be done. But this is the vision for the future, that we can improve our transportation system. And we try to not only improve in terms of the provision of the service, but I'm touching a lot of things here, like there's the actual highway infrastructure itself, the smart road, the actual operation of the vehicle, the smart drive. All this is trying to apply the technology to digitize the way that we grab the data, we process the data, we interact with the traveler, and also the way we manage our transportation system. So before going to the case study, I would like to give my view on what the digital transformation is all about, because this will come back later when I discuss case by case, okay? So digital transformation is of course two words, digital and transformation, okay? Digital we know, so thanks to the first speaker introduced us what digital meant. But I want to focus on the word transformation. So the top image, okay, so we're so excited when we saw Steve Jobs present the first iPhone, right? That's the way mobile phone is transformed. But since then, we just probably experience a different version of the same transformation. So that's just a change. But transformation is like the bottom figure here. It's just totally, it's like change the paradigm of presentation, of the usage, of the way it works. So this is a very key message, because when we talk about digital transformation, the situation in many countries and the case in Thailand is we try to fit in the digital tools into the same process. So it's mainly the change. So we try to fit in the automation, the digitization process into the same working and operational process. And I will show you later what's the problem with doing that. Okay? So with doing that, I think you prescribe only to what I call the subscribe to the vision. So somebody tell you, okay, you have to do this. Top-down approach, right? But when we do this in the practice, in transportation company or organization, a lot of resistance, okay? A lot of resistance. Unless you can transform the way that they prescribe to the vision. And mostly it's driven by tactics. Okay, tactics mean that, okay, now we're gonna force people to keep doing this to raise the KPI, the number of people who apply to the digital license, but not driven by the actual strategy, how it's improved the actual user experience, okay? And last but not least, I would like to highlight this bottom one. The external influence is very high for just making the change, but in terms of the transformation, we want to make it to be very minimal, okay? So this transformation happened in basically all the sector in our life. We know the content, the entertainment, the finance, okay? I just got the approval from BitCup just like 10 seconds ago, so very excited. Tomorrow I can be on the trading platform to lose the money, okay? At least I got some adrenaline going on, okay? But anyway, it's changed the way we see things, right? Between cryptocurrency and the way that we see the money. Same case for transportation services. And for Thailand, I think the four things that I saw what's going on and what's been happening in the past 5-6 years is that we try to transform what we call service transformations. Okay? Service can be transformed and has been transformed to some extent. We try to transform what we call the e-payment. Okay? And monitoring and management of the system. And last but not least, the data for the user and for the planning purpose. So I'll give you some example, okay, one by one with some thought on this. But before going to those nice picture and how things evolve into the application, this is my observation from the reality that going on in this digital transformation in Thailand. First, the principle of transformation is not there. Most of the time, we've been involved in the situation that we need to fit in the IT technology into the same process. Okay, into the same process. Like the same way the officer and those who are responsible for transportation services still do the same thing, but change it to be on the digital platform. Okay. Second, there is a very strong silo effect in Thailand in terms of the organization and the data transfer. I've been involved in some of the projects that cannot believe it, that it's a two departments within the same ministry that cannot link the data. Okay. And that's actually stopped all the transformation that we have our dream about. And we need to handle a lot of legacy system. Digital doesn't happen like, okay, tomorrow is a new digital transformation for transport. Now let's create a brand new system. No. There's a legacy data that already been going on for the last 10, 15 years. So we have to handle that. And our law and regulation is very outdated. It's totally against the concept of digital transformation, actually. And last but not least, I experienced a lot of lack of technical understanding from the both sides, those who are actually in the government side and also on the user side. So a lot of explanation need to be done. Otherwise, it's actually impede the way that we try to transform things. I will just give example of this. So let's go through one by one. First, the service transformation. What happened in Thailand? Okay. So I use example of Department of Land Transport, because this is a service to the user. So we need to go to land transport to do what? Apply driving license, renew our vehicle registration. So this is a service. So if you cannot transform this to be, on the digital platform, then it's the end of the story. So what's been going on at the DLT is that they try to remove the barrier of all this, the data usage. So anything that can be digitized, move into digital platform. Anything that can be done on the electronic platform, do it, okay? And anything that can become what we call the user-centered design, try to do it, but still within the same process of DLT. For example, you need to apply for vehicle license, then you need to present yourself at some counter, so forth and so on. So what we observe is a lot of systems that been developed, like this, the DLT e-booking. Okay, so please come, we are on the DLT e-booking platform. It's digital, but still you need to go to the center. So it's not go all the way, it's not transform the way that, okay, no more, we don't need to be at the location of this building anymore, okay? Just because of the legislation and the regulation and the way we work, it's still the same. So it's just a shame. So of course we can make a nice QR code and all this, but still it's the same process, okay? And okay, let's make it digital. So every form is online, okay? Every form can be online, right? But still you need to download, fill in the form, and then send it. And of course, this is according to some regulation and requirement of the way it works, okay? And the QR driving license, trying to make sure that, if you don't have the driving license with yourself, then you can present yourself with some QR code, okay? This is some proposal. Now you can see the sort of development, okay? And also what I mentioned previously, what's good and not good. This example of the case that vehicle inspection control is online. I think one of the successful cases that now in Thailand, if your vehicle more than 5 years, you need to go to some center to have some inspection of your vehicle. So it's all online connected. And just like a Thai style, then we want to make sure that those who, private sector that inspect the vehicle will not cheat, will not make up the record. So everything will be on the record, like even the video monitor, whether the person really, inspect the vehicles, okay? Or the reading on the sensor is transmitted online to the back-end center. So it's just like the same sort of transformation that we can see in Thailand. So it's go beyond the limit, not like the other country, okay? So what's gonna come up for the service side, okay, for DOT is like, we are talking about having what we call the RFID vehicle license, okay? We are talking about the driver merit point scheme, that now if you are not so good driver, your point get deducted, and then you need to be called on the e-learning to train yourself and to be a good driver again before you can continue. We're talking about a new vehicle ownership management, why we need to transfer the vehicle by presenting a piece of paper at the department, okay? And last but not least, we are talking about a new public transport license management. So, all the buses have the GPS, why we cannot regulate the way they provide the service through the data, rather than just send some guy, wait at the bus stop and, observe how they're doing. So this is on the service side, okay? The second one is on the payment. This is even a big transformation in Thailand. We are talking about, I think everyone in this room knows, we are talking about the so-called common ticket system in Thailand, which means that only one single device can be used to pay, to access all the transit service, okay? It's already been going on for like 10 years, 15 years, right? So what's going on in Thailand right now is that we are looking at this card-based scheme that become more and more advanced, and one card can use BTS, MRT, Red Line, the airport rail link, the same card. But we are so slow in doing this. So technology trend in the world moved to the account-based ticketing system called ABT, okay? And now the current position in Thailand is that we're gonna ignore this now. So we're gonna jump straight to the newest thing again, okay? And what's gonna happen is that now the new type of the common ticket policy, any type of media that you can identify yourself, okay? The cash value will not be on the medium anymore. It will be stored in some account, like our bank account. So if you can identify yourself with this medium, and then can be related to this account that you registered beforehand, then you can use the transit system. Okay, it's just very basic concept, but a lot of technical jargon. And the challenge in Thailand on this very simple digital transformation is that we have so many operators. Okay, even in front of this building, we have the Go Line, which belong to one of the operators, right? If you go across the other side of Bangkok, then you have another operator. So all these guys currently have so different type of device and the system that they have so far, and they invested a lot of money so far. So it's so hard to make this so-called digital transformation that one single account-based ticketing system can be used throughout the whole network. I almost say it's impossible, okay? Because a lot of investment and a lot of kind of negotiation going on. But what's going to happen, I think, at least from this current card-based scheme that we are using so far, we're going to move toward this account-based ticketing system deployment. Because now there's a current development on the purple line and blue line that going on at the moment that they will develop this ABT, okay, ABT system. And that will tie into the type of the card, okay, according to the EMV standard. It means that you don't need to get this type of card anymore. You just get your normal credit card, debit card that have the EMV and the Visa, Master, Union Pay on your card. And then the system will go through the whole payment gateway and identify yourself. The only key difference compared to the normal credit card that we used to pay to buy a coffee at Starbucks is that there need to be this what we call like a payment reconciliation or this ABT system at the middle so that we can implement common fare. It means that when you pass a certain number of transit line, you don't charge twice for the first entry. That's what we call the common fare table, right? So this has been like going on a development so far, and I think hopefully between now and the end of like June, we can see this deployment on the first few lines, okay, in MRT in this case. The second e-payment thing that I think the first speaker mentioned about is this M-Flow, okay, M-Flow. So the basic concept, like, that it's just so strange that we have this congestion because we build the toll road to make the vehicle go faster, okay, but then we spend so much time queuing to make the payment. And like this picture here, you add even 2-3 different stacks to just even make more lane for payment. It's still the congestion keep going up. So this project trying to tackle this problem, just the basic technology is that just remove the toll barrier. That's it. Okay. Whatever technology, whatever the process that need to overcome, we need to overcome it. So a lot of challenge on this digital transformations, like, okay, what is the regulation improvement? Okay, how can I send the bill to those who doesn't pay the toll? Okay, what is the way that can enforce this legal issue? Okay, we spent like almost 3 months discussing the case that if the driver is not the owner of the vehicles, is he the culprit? The same case of all this legal issue for the traffic law. Okay, so this is what I meant about the obstacle to digital transformation. We know he's using the vehicles, right? But why we just read so much detail in the text on who is a culprit? Okay, there's a lot of challenge on linking in this system here. Okay, so here you have this lane system, very high-tech technology, or this LiDAR vehicle, whatever. What it does is that it just detects the vehicle, identify the vehicle by license plate. Okay, maybe additional RFID can be attached, doesn't matter. But to verify that this person, if it's a normal vehicle, it's okay. But if it's a large type of vehicle, again, the legal system, not the legal, but declaration of the toll system in Thailand is like 2,497. It's like a Buddhist year. I don't know what is. So it's like the first time that Thailand have this system. So they define such that the vehicle class defined by the number of wheels and axle. There's no LiDAR. There's nothing that can operate 24/7 in the next 5 years consistently to identify the number of wheels and axle of the vehicle. So we need to link the system to those services that I mentioned in the first few slides, okay? Because supposedly they should have this registration, right? That this vehicle have this number of axle, have this number of wheels. So digital transmission sounds straightforward, but no, it's not that straightforward. Because the quality of data that input from here, like I say, the legacy system of the data, okay, the number of vehicles in Thailand, I don't know how many, but maybe more than population of Thailand that ever been in terms of registration. The guy like 10 years ago who input the data doesn't feel like it's so important to identify correctly, okay, the number of wheels and number of axle. But now it's become legal issue that we cannot detect the exact number of wheel and the number of axle. But anyway, this is a part. Another part is this personal identification. To make this digital transformation, when you register for this M-Flow, you need to identify yourself. Like you apply for this Bitcup or this cryptocurrency. Just because there is a big law on this KYC, your customer law, if you have the digital account for payment. And that's why you need to input your national ID, take your photo, blah, 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 okay? Just to make sure that you really identify yourself. But again, that's another hurdle on digital transformation in transportation sector because nobody would like to do this, right? Nobody would like to keep inputting the data. But apart from that, I would call the core process and the administration process in this part has been totally redesigned because the way the toll collection has been made in the past cannot be applied to this new case because before it's a prepaid. You pay before you use, right? Even the easy part and M-Pass. But this new system will be such that you actually can do the post-pay, like a normal credit card that you pay, buy the merchandise and then you pay at the end of the bill, okay, cycle. So the whole process has to be reinvented in this case, okay? And the technology part, of course, I'm not gonna repeat what other people, so it's a lot of like verification in terms of the vehicle license plate, the AI, okay, the camera. I myself been doing a lot of research on this, of course, before, and always have the skeptical feeling about whether it's, but once you actually implement it on the field and you see the gradual improvement in terms of accuracy, you start to believe it, that it's really going to work. So the current situation is that this AI camera will detect the number plate, okay, at this entry point, and we identify the vehicle by the database of this number plate, classify them by registration from the service part that have this database. If the AI is not sure about this, of course, is machine learning, then the manual will intervene, okay, the manual license plate recognition, so input what he saw, okay, in terms of the actual number plate and the vehicle type. And this data will be kept for the next learning process. Because if those of you who do this or who know about this, then it's not like OCR. It's not like trying to characterize each letter. This trying to learn the whole image as like our facial recognition in this case. Okay. So on this country side, a lot of equipment just to show that it's not like just one camera, but it's a combination of LiDAR, like the previous speaker mentioned about, trying to get the profile vehicle and do the time sequencing of the vehicle to match the license with the transaction time, okay? And the first phase implement like 4 toll plaza on the motorway, route number 9, okay, number 9. And again, this is another example. When we do transformation, we still want to allow people to use the existing one here. But it's present as very challenging, traffic engineering design, okay? How to make it to be still safe that you have, 100, 120 kilometers per hour free flow tolling, but still you need to allow for people who would like to pay by cache and those who would like to use the still normal MPass system. So as another like case study on this transformation, it's easy to go 100%, okay? Like the previous speaker mentioned. If you have autonomous vehicle, 100% is not that complex. The most complicated thing is when you have the mix of the two. 50% is a manual vehicle and 50% is an autonomous vehicle in this case. So different location of this toll point, okay? And the test is going on for like 6-7 months now. The ALPR is about 98.2%, okay? And of course, somebody asked, what happened with 1.78%? Then, of course, it's go to this manual processing. So it's like an army of staff that sit in the big room and keep correcting this. And we learned this from different experience throughout the world, that this also going on when they apply this type of tolling scheme, okay, in the new project. And this system will allow the payment, okay, throughout the different channel, like the credit card, debit card, and counter service as well. But of course, another lesson we learned is that when you present this type of thing, then Thai people is Jairon, I don't know, want to use this. Okay, why I cannot use this? Why I cannot use that? Right? But sometimes they forget that it's much better than the previous version already. Okay. So for example, at the moment, the connecting link to the counter service is not yet 100% completed. Okay, so probably need another 2-3 months to do that. But apart from that, mobile banking, Visa, credit card already been implemented. Okay. So the next one, I don't know how much time I have left. It's gone, right? 5 minutes. This one I talked a lot before that, okay, in Thailand we also transform the way we monitor and operate the vehicles, particularly transit vehicle and also the large vehicle to ensure the safety. So the GPS device has been announced to enforce that each vehicle connect this GPS device to their vehicles and send the data back real-time basis for the monitoring and control of the vehicle speed and the hour of work. Okay, so this has been going on already in Thailand. And again, in Thailand, the obstacle is that there are so many type of quality of this device, and the back-end engine need to work so hard to separate the good data and the bad data. Otherwise, the safety matter cannot be discussed without the good quality of the data. Okay, but at least during that time, in the first period that we applied this, the average speed of this type of vehicle drastically reduced. Okay, but it doesn't mean it solved the traffic accident. Okay, I often saw the news and say, okay, still why GPS doesn't work? Of course, it doesn't fix the driver behavior, but it's enforced at least another element of risk. Okay, in this case. So we cannot rely only on digital transformation to solve traffic safety problem. So what's going to come up? Okay, there will be more additional usage of this system for the what we call transportation regulation. Okay, and as you heard, the DLT is doing this app-based share ride service, and trying to solve the same question is trying to link the monitoring service of this rider into the same platform. Okay, and also trying to allow the data to be utilized more for other purposes. But then we still need to face this PDPA and all this agreement issue, and upgrade to the 5G technology to have a more accurate location of this. Okay, and another going on is this monitoring management that probably I mentioned before. There's an attempt to monitor the whole system, okay, using the CCTV camera and the management system. So it's now almost 50% completed, I'll say, okay, and cover quite a large number of segments, okay. But I think next year it will integrate the normal highway system in Thailand with the motorway network, because we realize there is still congestion in the interface between the two systems. And this variable speed management and the speed enforcement will be deployed, particularly on the location. Okay, okay, very quick. So the last one is the data management. I mentioned about this before. The 5G network is used for the bus arrival time information, and this app that OTP utilizes the same GPS data to provide the bus location service. Okay, and now the Ministry of Transport try to pull all the data together to share with all the organization, okay, for planning purpose. Okay, and the latest development from the OTP is that all the data I mentioned cannot interpret to the real behavior. So now we are trying to use this data to interpret to the normal, for example, like what Dr. Passakon mentioned. if you have the GPS, the location of the people movement, my mobile phone, how do we figure out that what is he doing? Okay, in terms of his behavior. And now it's going on in terms of the development for the OTP. Okay? Okay, so just to wrap up, I think this, from what I experienced so far, still this 5 issue is still the main challenge for digital transformation. Technology is one thing, but we still need a lot to help to move this implementation to the real world in Thailand. Okay? Thanks a lot for your attention. Thank you.
Thank you very much. And I think we still have some time to discuss and answer for the questions from the floor here and online. Can I invite all the speakers to come up on the stage, please? And Professor KAMIJO, will you hang around over there? Okay. If anyone has any question, you could raise your hand, get the microphone right here, or if someone knows if there are any questions online on Zoom, could you please just speak it out loud, please? Yes? One person there, please. Microphone, please. Yeah, microphone, please.
Thank you very much. My name is Yamashita. I'm coming from the Japan Transport and Tourism Research Institute, ASEAN India Regional Office. Thank you very much. Very good, wonderful presentation from the 3 persons. I have a question to the Mr. Agachai, and regarding the payment system in the railway system. I've been feeling very inconvenient when I use the different operators railway lines, because the different card we should use the different lines. So the information from you provided us is very interesting in for me, the payment using the credit card. And this is the, maybe 2 questions. I have missed the introduced timing. On the slide, purple line and the blue line is already introduced or introduced in the near future. I missed the information about the timing. And the second one, is this the original idea in the Thailand or other country already introduced in the world? I have 2 questions. Thank you very much.
Okay, thanks a lot for your question. The system is already implemented for the purple line and the blue line. Okay, but because it's an EMV standard, so you need to pass what we call the certification level, and now they are under the final one for the certification level 3. Which means that one is actually being passed, then it can be used. What I know is that I'm the chair of the subcommittee on the common ticket. So the information that I got is that it will be able to allow the public to use, I think, within the next 6 months or so. Okay, this is the first question. But only these 2 lie. Okay, only these 2 lie. So Thailand is a step by step. Okay, we are a careful nation. Okay. And second question, yes, I mean, EMV has pushed very hard for the scheme for transit payment. And I think the example that I can mention is the Transport for London. So if you go to London, okay, if you have some credit card, then you can immediately use it for your transit travel, okay, in that case. So that's probably answer your 2 questions. Thank you.
Thank you very much.
Thank you. Any question, please? Perhaps we are curious. Okay, when we have blue line, purple line, What will be the next slide then? That will be integrated on the payment. Okay, please.
Yeah. Thank you for nice presentation. Dr. Professor Agachai mentioned a lot about applications for DLT, for the fire collection, for the rail, and I wonder about the taxi operation, because in the past, the major problem is the empty cruise. I don't know the situation now. Is empty cruise decrease or increase? And the average travel of the taxi maybe decrease compared to the past. Please mention.
I think the data I saw from the taxi OK statistic is like now only half of the taxi is under operation. It's not even about empty cruise or cruise, because during the COVID situation, a lot of people gave up the operation. So I will check for you in terms of the actual statistic on the empty haul, okay, so to show the efficiency of the system. But we do have the data. Yes.
Okay, we have to be speed up a little bit because we run out of time. Any question? Yes, in the back, please.
Okay, hello. Thank you very much for your nice presentation. Okay, my name is Atapon Aliyalit, come from Sulanali University of Technology. Now I'm also working on the autonomous driving. So I'm really interested about the Professor KAMIJO work. Okay, can I ask you? Okay, so now in our laboratory, I also use the LiDAR and the camera together. Okay, so I think however the weak point of the LiDAR is the equipment is really expensive. Okay, do you have any idea to reduce this cost or share it to another sensor? Is it possible to do that, or do you have any idea?
It's a very difficult question because I do not produce the LiDAR by myself. But recently, LiDAR is getting cheaper and cheaper, actually. So we can buy the 16 beam LiDAR less than $10,000 today, getting cheaper and cheaper. So I hope in the next 10 year and 20 year, it's getting much more cheaper, 1/4 or 1/5 of today's. So we are using the experiment. Actually, our laboratory is not a rich laboratory, so we are using 16 beam LiDAR, very cheap one. And it is, we can make localization by ourselves. So number of beam is another problem to reduce the cost of LiDAR. And 4 beam is not possible to make a localization. 16 beam is a minimum. In my impression, just the impression, not the scientific, but just the impression, 16 beam is a minimum number of beams to make a localization. But in my impression, in another 10 years, 20 years, if the autonomous driving is more popular, it getting 1/5 or 1/4 price of today, I hope.
Okay.
Did I answer you?
Yes, okay, thank you very much for your nice answer.
Yeah. Thank you, Professor
Thank you.
KAMIJO. And can I have one last, quick question to Dr. Passakon? You mentioned a lot of technologies that can be used for smart mobility for the smart city. In your opinion, what you like to see? Some technologies that could be deployed in Thailand?
I don't think that I expect to see the technologies, but I want to see the manpower, the talent of the people, how to, educate people to consume or to utilize the technology smartly. Because actually it's very fast, but we need the human being, the manpower. Otherwise we become only the users. We want to be the developer also.
Thank you very much. Very nice comments. Okay, I think time is up. I would like to thank all speakers for today's session and also participants here in this room and also online. Okay, let's give all the speakers a round of applause, please. Thank you very much, KAMIJO.